Alright, this is a part that I'm really not looking forward to. If there's a method that needs cleaning up, it is this one. Well, obviously I went through 6 different iterations trying to get the playerSprite's update method to work correctly. Most of this method, though not all of it, has to do with collision detection. Let's see, where do I begin? I guess I'll just go chronologically. Sparkle ticks. Essentially, when you change from one player character to another, there's this static, it's predetermined, a predetermined animation of sparkles that sort of plays every time you hit one of the E, R, T, A, D, F buttons to change from one pony to another. If we're in the middle of what passes for a cutscene at this point, which is generally either the rainbow elemental dragging you to a given place, or if we're in the middle of a dialogue, then we just return out of the update method immediately. Let's see. If we're invulnerable, then for some reason we count up the number of invulnerability ticks. I'm not exactly sure why I do that, but I do. This is a persistent Boolean which I use elsewhere. Pay attention to the next X position and the next Y position. There's probably a lot of variables that I used at one point thinking that I was going to need them, or that I used in earlier versions of this method, because obviously I've done 6 different versions of it, and this is just the latest and greatest. Let's see. First, I act like the current position of the player character is the one that's important for collision detection. I check to see if the player is interacting, which amounts to, is the user pressing the enter key or not. I've always wanted to do a platformer where the enter key is your interact key. I don't know why, but I have ever since I played Mario is Missing for the Super Nintendo. But anyways, first we check to see if the player character's collision rect intersects with the door's collision rect. If there is an intersection, then we say, okay, the player character is going through that door. We just return straight out of that and tell the pony panel, hey, we're using this door. If the player character intersects a radio sprite, we have the radio start playing its thing. This handle nudges method is one of the things that the code Nazis would tell me to do with this method, which is to break off pieces of it into little bite-sized chunks. This one handles something called a nudge. When let's see, when a moving block decides, okay, the player character is standing on top of me and I'm going to the right, therefore the player character should move with me, it adds a nudge to the player character. It does the same thing for conveyor belts and custom NPCs that function as platforms that are moving. First, we get an ordered list of the nudges, because we basically get an unordered list. And the higher up the block is, well, that determines where it is in the list. I believe the higher the block is, the earlier it is in the list, I think. Yeah, the higher the block, the earlier in the list. Let's see. Then for some reason we iterate through the list starting at the first one. And we change the next X position and the next Y position based on the nudges. And if we've got a nudge telling us to go down, and the nudge says you should go down through, pass through floors, I believe this is when there's a block that's a moving block that's the ceiling. You're standing on a pass-through platform, and this solid moving block is going to push you down through the pass-through floor. That is the one way that you can get through pass-through floors in the current game engine. And we sort of hang on to this Boolean for later on. So that's the handle nudges method. The code Nazis would tell me to take out all the commented stuff and scrunch it down so that it's all on one screen. Blah. I can see cleaning up the comments here, but honestly, I don't like small methods for small methods' sake. Anyways, we go through the list of custom NPCs here and create essentially a list of custom NPC blocks. The block interface is something that I created for collision detection purposes. Custom NPC block interface is a special case of that. Let's see. Basically, the constructor and this getCollisionRect method are checking to see, okay, does the custom NPC have an actual collision detection hitbox with blocks that can be used on the player? If they can, then we add the custom NPC to this custom NPC blocks array list here. How am I doing for time? I got plenty of time. Don't know if I'll get through the whole thing in one video, though. Let's see. For the most part, the collision detection hitbox that we use is collision detection hitbox around the player character's next position. This is essentially the floor, or what? In this case, it's the hooves, the soles of the feet of the player character. That's what this player next max y variable is all about. And we check to see whether the next position is lower. Don't remember where exactly we use this, but we do. The first thing that we do is we try to determine the ceiling and the floor for this. And we start with the ceiling. We say, okay, block manager, which is essentially the tile map, get me the ceiling block based on everything that you know about this player character's position. This is encapsulated in its own little method. Actually, that's probably not all that little, but oh well. After that, I pass in blocks, which is essentially all the moving blocks and all the conveyors, and it tries to find an alternate ceiling based on that. And if it finds a ceiling that's closer to the player than the existing ceiling block, then we replace the existing ceiling block with that new ceiling. We do the exact same thing for all the custom NPCs, and then we also check to see if the goal can function as a ceiling block. Let's see. Let's see if the next position is lower, and we should nudge through, pass through blocks. Then we once again try to find the floor block. And we once again try to find the floor block from the rogue blocks and the custom NPCs. And now that oh, right. We've gone through the ceiling stuff, but we haven't gone through the floor yet. So this is the code that tries to figure out what the floor block should be. And the algorithm, obviously I've gone through this algorithm a few times as well. I won't get into this method here, just for simplicity's sake. We also check to see if the goal can function as a floor block. And I do not know why I have this Boolean. Apparently it's a holdover from a previous version of this, but I actually check this later on and try to get the floor block again for some reason. Here I check to see whether the ceiling and the floor are so close together that they are that they would crush the player. I get the player's collision block height, and if that's less than the difference between the floor block and the ceiling block, and the floor block is not passed through, crunch, tell the panel that the player died. Let's see. And I have 3 different vertical modes for the player character. There's not falling, which is essentially standing on the ground. There's falling, and there's jumping. And depending on the vertical mode, we do we take different actions. You can just ignore this diagnostic.print stuff. We're setting this floor block collision rect min y, which is essentially the top of the floor block. And if it turns out that there is no floor block at all underneath the player character, that's a sign that we should be falling down. If the floor block is beneath the soles of the feet of the player, like more than 1 pixel beneath, then we switch to falling as well. Let's see. If the floor block is in fact above the soles of the feet of the player, then that's a sign that, okay, this floor block might be moving up, so we need to push the player upwards. So next position, we subtract the difference here to push the player character upwards. Let's see. If player is going up, I believe that amounts to the user is pressing the up arrow key. And keep in mind, this whole code block is if the player isn't falling, i.e. if they're standing or walking. Then if the user is pressing the up button, then we switch to the jumping one, and we set the jump ticks to the maximum number of jump ticks, which is 15 in this case. Obviously, I'm going to have to revise this. Actually, I'm going to have to revise a whole bunch of things here if I'm going to add flight to the game. Long term, I would like to, but I don't know whether that's going to happen or how soon it's going to be. Actually, I'm pretty much determined to make it happen because I want to add a plot point where you can get Rainbow Dash some type of rain gear that protects her wings, and then she can fly. But that's another story. Actually, there's a couple other modes too. There's recoiling. If the player's taken damage, they sort of bounce backwards. As soon as the player character releases the up button, then we switch from jumping to falling. As soon as we're done recoiling left or right, then it's impossible for us to reach these conditions at this point in the code. That's another thing that needs to be cleaned up. Anyways, if the player character releases the up button, then we switch to the falling. I believe here we check to see whether the player has bonked their heads on the ceiling. If not, we go upwards by the jump step, which is 12 here. I don't know why we have these former ones when... okay, they're just used for a logger. Otherwise, if there's a ceiling block, then we move the player character up either 12 pixels or however high it takes to bonk the player's head onto the ceiling block. Also decrement jump ticks. If the jump ticks go to 0, or if, let's see, once again, this is impossible, but we switch to falling there. And if the ceiling is too low, that means we're already bonked, so switch to falling there. And here we have the falling block. And I don't know why we have this if statement here, because already established floor block is always going to be true. I could just take that whole thing out. If the floor block is null, that means the player character is standing over a bottomless pit, and there's no floor, so we fall down by fall step, which is 10. Otherwise, we check to see whether we check to see how far it is to the ground, and let's see here. This is the difference between the soles of the player character's feet and the floor. And we want to move the player down either that distance or the distance of falling per tick, whichever one is less. And if the lesser of those is in fact the distance to the floor, then that means we're done falling and we switch to not falling for the vertical mode. I think here is a pretty good place to stop. That's pretty much the vertical position collision detection right there. We go through a similar song and dance with the horizontal, but I'll start that with my next video.